When applying adjustment factors for multiple current carrying conductors in a raceway or cable, the temperature rating of the terminals dictates which column of the ampacity table, specifically Table 310.16 in the National Electrical Code, you must use for rating. In the scenario where there are 6 number 8 THHN current carrying conductors in a conduit, and the terminals are rated for 60 degrees Celsius, you must use the 60 degrees Celsius column in Table 310.16 to determine the appropriate adjustment factor. Section 310.16a of the National Electrical Code explicitly states that adjustment factors for more than 3 current carrying conductors in a raceway or cable are to be determined as shown in Table 310.16 based on the number of conductors and the ambient temperature. Therefore, even though the THHN insulation of the wire itself is rated for 90 degrees Celsius in dry locations, because the terminals are only rated for 60 degrees Celsius, the 60 degrees Celsius temperature rating becomes the limiting factor for the entire circuit. Using the 60 degrees Celsius column, Table 310.16 provides the adjustment factor for 6 current carrying conductors. For 6 current carrying conductors, the adjustment factor is 0.82. This means that the allowable ampacity of each conductor must be reduced by 18%, which is calculated as 1 minus 0.82. This data ensures that the conductors do not exceed the temperature rating of the weakest link in the chain, in this case, the terminals. The ampacity of number 8 THHN wire in the 90 degrees Celsius column of Table 310.16 is 55 amps. However, because the terminals are rated at 60 degrees Celsius, you must use the ampacity listed in the 60 degrees Celsius column. The ampacity of number 8 wire in the 60 degrees Celsius column is 40 amps. After applying the adjustment factor of 0.82 for 6 current carrying conductors, the adjusted ampacity becomes 40 amps multiplied by 0.82, which equals 32.8 amps. Therefore, the maximum allowable current for each number 8 THHN conductor in this scenario is 32.8 amps. It is critical to always use the lowest temperature rating between the conductor insulation and the terminals to ensure compliance with the National Electrical Code and to prevent overheating, insulation damage, and potential fire hazards. Always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date requirements. When determining the allowable ampacity of conductors, firstly identify the conductor type and its insulation temperature rating. Secondly, determine the temperature rating of the connected terminals and any other devices in the circuit. Thirdly, select the lowest temperature rating from the conductor insulation and terminal ratings. Fourthly, use the appropriate ampacity column in Table 310.16 of the National Electrical Code corresponding to the selected temperature rating. Fifthly, determine the number of current carrying conductors in the raceway or cable. Sixthly, apply the adjustment factors from Table 310.16 for the number of current carrying conductors. Seventhly, calculate the adjusted ampacity by multiplying the ampacity from the table by the adjustment factor. Finally, ensure that the calculated ampacity is suitable for the overcurrent protection device, such as a circuit breaker or a fuse, to protect the circuit from overloads and short circuits. Remember that other factors, such as ambient temperature and voltage drop, may also affect the allowable ampacity of conductors. Ambient temperature corrections are addressed in 310.15c. Voltage drop calculations are typically performed to ensure that the voltage at the load remains within acceptable limits, which is typically plus or minus 5% of the nominal voltage. Voltage drop is addressed in Informational Note number 1 of 210.19 AON and Informational Note number 4 of 215.2 AON. These notes typically point to Chapter 9 for calculation methodologies.